Okay guys, what we're going to have a look at today are moles calculations for the GCSE double award specification. Specifically, we're going to look at the very first section within this refers to things called RAM, RFM and RMM. Those three things will be linked together, and that we will convert them to moles using a simple equation, and we will convert moles back to RAM, RFM and RMM again using the same equation. So let's start. You need to make sure that you have a calculator and a periodic table. So if you don't, pause this and go and get them. The equation that we're going to use is N equals mass in grams divided by the MR, and the MR is simply the RFM, the RAM, or the RMM as covered in the previous video. N will be used to represent number of moles of a substance, and M will simply mean mass of that substance in grams. That is either normally given to you in the question by the examiner, or perhaps you'll have to work it out from the number of moles and the MR. So moving on. What we're going to do first of all are a few sample calculations, and then we will hand over to you to do a few. So we're going to calculate N, which is the number of moles of oxygen in 32 grams of oxygen. Okay, so the examiner has given us the mass of oxygen that we have. We've got to use the equation, which if we remember is N, number of moles, equals M, which is mass, divided by MR, which is the relative atomic mass. So the subject of our equation for this purpose is N, number of moles. The mass, which the examiner has given us, is 32, which is grams, and the MR, we go to the periodic table and we find oxygen, which is 16, and obviously oxygen is diatomic and therefore is O2, so that is 16 times 2, which is 32. So this is a very easy example, as you can see, that I've used to introduce moles to you. And the mass is 32, the MR is 32, therefore in 32 grams of oxygen we have of course got 1 mole of oxygen. So that's pretty simple. Now we'll make these slightly more complicated as we go along, so let's move on to the second example. This time what we're going to do is calculate again the number of moles, N. And this time it's going to be of calcium hydroxide. So we've introduced brackets. This time is probably the only complication, and we've got 5.6 grams. So we're not working on quite as nice a round number of grams as we did previously. Again, just to remind you of the formula, being mass over MR, which is the relative atomic, relative formula, relative molecular mass, whatever you want. Mass being 5.6, which is what the examiner has given us in the question, and the MR is 40 for the calcium, and remember then we have brackets, so we have 2 oxygen, which is 16 times 2 or 32, and we have 2 hydrogens, which is obviously 2. So the MR of calcium hydroxide is indeed 74. So our calculation is essentially 5.6 divided by 74. Mass of sample divided by the mass of 1 mole of the sample, or the MR of the sample. That gives us an answer of 0.0757, and we've put that into 3 significant figures. Try and write all your answers in moles calculations to 3 sig fig, please. That's pretty much the standard way in which it is done. So therefore, the number of moles in 5.6 grams of calcium hydroxide is indeed 0.0757 moles. Okay, let's move on to another worked example. This time we are going to calculate the mass. So we've changed the subject of the equation from moles to mass of 0.3 moles, 0.3 N of magnesium oxide. So we've just got to change the subject of our equation around this time from moles as it was previously. This time it is mass M. Okay, so moles and MR are on the bottom line together, so mass equals moles multiplied by MR. Moles from the question, is 0.3. The MR, we go to our periodic table and again we calculate it out. Magnesium is 24, oxygen is 16 mass number, so the MR is of course therefore 40. So the mass in grams of magnesium oxide and 0.3 moles of magnesium oxide is 12 grams, which is 0.3 multiplied by 40. Okay, so it's as simple as that. We've manipulated this around to be you to use moles as our subject and to use mass as our subject, and that's pretty standard of what will be expected of you in GCSE calculations. So we'll again do a second worked example about calculating the mass, this time of 1.49 moles of our old friend ammonium phosphate. The reason why I use ammonium phosphate a lot is because it's a fairly complicated formula for you guys at GCSE, but you should be pretty comfortable with it by now. We did it in the first video and we're doing it again now. So we have 3 nitrogens, each of which have a mass of 14, remember, and this in brackets, so everything in the brackets is multiplied by what comes after the brackets. We've 4 times 3 hydrogens, we've 1 phosphorus, and we have 4 oxygens in our P4, so 16 times 4 for each of the oxygens. And that gives us a total MR, if you can't remember from the previous video, of 149. So again we have our equation. If you remember, we have to change the subject of the equation from the previous time to make it mass. Mass equals number of moles multiplied by MR. The number of moles is given to us in the question and is 1.49, and the MR of that is, as we've worked it out, at 149. So the mass of ammonium phosphate and 1.49 moles of ammonium phosphate is 222 grams of ammonium phosphate. So what we will do then is move on to a few more examples here. Okay, so ignore that. Okay, so what I would like you guys to do is question 3 that is on the board now, or on the screen as it were. So I'll blow it up here a little bit so that you can see it fairly clearly. And I would essentially like you to do and work out the mass, what mass of each of these numbers of moles of question 3A, B, C, D and E. Okay, so if I'll just cut this out for you and put it into the interactive whiteboard package, and I'll blow it up for you a little bit here so that it's nice and clear. I'm not sure how this will come out on the actual video, so I'll make it as big and as clear as I possibly can here. And what you can do is get your periodic table and get your calculator and pause the video, go away, have a go at these, and then come back and check the answers. So the answers are coming up now. So they are as follows. All the units for these are obviously mass, so they're all, the units are in grams, so you can check your answer and make sure that you got what I am writing on the board here at the minute. So these are fairly straightforward, but they are fairly decent examples of what you will be asked to do in GCSE Moles calculations. So hopefully you got A, B, C, D right, etc. So again, you can pause the video and have a go at these. This time it's calculate number of moles. Last time was mass, so you have to manipulate the subject of the equation. You can pause the video and I will put the answers up to these. Okay, so if you remember that number of moles is equal to mass multiplied by MR, unlike the last one where mass was equal to, that is in fact wrong. It's number of moles equals mass divided by MR for those of you who are switched on. Okay, so please ignore the formula at the bottom left hand corner of this screen. Okay, get your periodic table in your calculator, go do them. Pause the video and come back. Okay, so the answer to F is as follows. Okay, so that's your calculation. It's 47.3 grams of F divided by the RFM. 2 sodiums, 1 sulfur at 32 and 16 times 4 for your oxygens. And that gives you a number of moles of 0.3 moles. So in 47.3 grams of sodium sulfate you have 0.333 moles. Again, write it to 3 significant figures, please. Okay, let's move on and have a look at our aluminium hydroxide. So we've got 0.78 grams of aluminium hydroxide, so we need to put that on the top line, and on the bottom line then we will put the RFM of aluminium hydroxide, and that calculates out at 0.01 moles. Okay, then we move on to our 8 grams of ammonium nitrate. Again, we have 1 nitrogen, 4 hydrogens, 2 nitrogens, 4 hydrogens and 3 oxygens in our ammonium nitrate. I'll just rub out these annotations which have crept in, and that is 0.1 moles again. Okay, let's move on to our old friend ammonium phosphate. We should hopefully know by now that the RFM of this is 149. We have 298 grams, so our calculation obviously will be 298 divided by 149. Some of you, I would hope, would be able to do that in your head. Those of you who do need to get your calculator out, it's not going to take you very long. It is indeed 249 divided by 149, which is obviously 2. Okay, moving on then into J. So J is our first organic compound, which is ethanol. Hopefully some of you will remember from your organic chemistry. It has 2 carbons, it has 6 hydrogens, and it has 1 oxygen. So if we tot all of those up and we put it over 0.92, the calculation we're doing is 0.92 divided by 46. So the answer works out at 0.02. So like GCSE, a lot of those have worked out at fairly nice round numbers. We don't have to worry too much about decimal places and significant figures when it just works out at 1 decimal place and 1 significant figure. Okay guys, I hope you enjoyed this and found it useful. Well, the next video will come along soon.